Okay, ready? So here's a couple practice problems. You always try substitution first, but when you plug in 0, you get 0 in the denominator, so you have to try one of the methods. This method is factoring. Greatest common factor in the numerator is x times x plus 8 over x. Allows you to cancel the x's and then plug in 0, so you get 8. And actually, what would this look like if on my test, this was on the calculator portion, plug in x squared plus 8 plus 8x divided, ooh, this is rough. Okay, divided by x. If I go to 0 in the table, why? You know how to do that now? Oh, so see how I'm undefined at 0, so I can't see it, but the table looks like it is approaching 8, right? So the table is another way to check that 8 makes sense. Okay, next one. I try substitution. Plugging in 6. Oops, I can't do it because I get 0 in the denominator. This is a right-sided limit because of that little plus sign. So if it had just said 6, the limit does not exist because the graph is going like this at the asymptote. But if I show you what it looks like on the graph, 1 divided by x minus 6. So at 6, there's an asymptote. This end is going down and this end is going up, so the limit does not exist. They wanted the limit as x approaches 6 from the right. The answer is positive infinity. This you'd have to look at a graph. So the answer is positive infinity. Number 3 is a constant function. Y equals 9 is a constant function. Does it matter what I'm plugging in for x? Nope. The function is always equal to 9 no matter what I plug in for x. So that's a constant function. That's another rule for limits. All right, the next one. Again, you try to plug in 1, but I can't because I get 0 in the denominator. Is there anything I can cancel or factor? No, right? I could try factoring x plus 1, x minus 1. 1 is still undefined. It's still an asymptote. The graph's going this way. So number 4, when you look at the graph and they go different directions, is D and E does not exist. Did we get that? Does that make sense how 4 is different than 2? 2 and 4 are both asking you about an asymptote, not a whole, an asymptote. This one, I can find one side of the limit, but I can't find the overall limit. And if you looked at what the graph looks like, x plus 9 divided by x squared minus 1, at positive 1, there's an asymptote, and this side of the graph is approaching positive infinity, and this side of the graph is approaching negative infinity. They don't approach the same value, so the limit does not exist. Number 5, I plug in -3, I get 0 in the denominator. I try factoring. This can factor into x plus 3, x plus 2. The x plus 3's nicely cancel. I plug in -3 and I get -1, right? -3 plus 2. So the answer would be -1. So that's a case when factoring helped you. You can try factoring. Sometimes it'll help you. Sometimes it won't help you. So you have to know the difference. All of these were substitution and they all failed by substitution. So you have to use one of the other methods. All right, here's dominant terms. How do I know it's talking about dominant terms? X is approaching infinity and negative infinity. So I have to use dominant terms. I compare the power. Powers are equal. They're both x squared. So we can strip the coefficients. 3 divided by 1 is 3. Same rule for the asymptote of a rational function. All right, this time when I compare the numerator and the denominator, the numerator wins. So it's going to blow up. It's going to get really big or really small. So when I plug in a negative and square it, I get a positive result in the numerator. When I plug in a negative into the x, I get a negative. So positive divided by negative will approach negative infinity as your answer. The only other rule that I didn't put up here is when the denominator blows up. So if it had been like the limit as x approaches infinity of 1 over x plus 2, denominator blows up, it approaches 0. So those are your dominant rule package right there. And then 8 and 9, 8 was the conjugate. So I try to plug in 3. Can't. I see a square root. So the method for square roots is multiplying by the conjugate of the radical term. So the conjugate is the square root of x plus 1 plus 2. Square root of x plus 1 plus 2. So the only thing that is opposite, if this is a negative, this term gets a positive. So when you multiply, square root times square root will just give you x plus 1 in the numerator. Outer plus inner would add up to 0, 2 radicals and negative 2 radicals. And then negative 2 times 2 is negative 4. So you get x plus 1 minus 4 in the numerator, which is x minus 3. So the x minus 3's cancel. So all you have left is 1 over this denominator. You have 1 over square root of x plus 1 plus 2. And we're trying to plug in 3. So 1 over the square root of 4. Square root of 4 is 2. Plus 2 is 4. So the answer is 1/4. I would say conjugate's the most challenging of the methods. You have to be able to multiply by the conjugate. Something cancels. You plug in the results and get your answer. So if number 8 on the warm-up is the one that needs the most practice, that's good because there's only like going to be 1 or 2 conjugates on the whole test. There's so many other methods to look at. All right, and then the last one, I plug in 0, I can't. So I can simplify the numerator using FOIL. X plus 4 times x plus 4 is x squared plus 8x plus 16 minus 16. So this one actually gives you the same answer as the first one, right? X squared plus 8x over x. That's the same thing we already did in number 1. X times x plus 8 over x approaches 8 when you plug in 0.